So, dear friends, I welcome you again in this class. I'm very happy to be with you and hope that you are doing well. So, we continue with the topic. Last time I told you some references. Hope you have received all the books. Have you received them? Have you received the literature? Hello?
Sir, yes, received.
Okay. And I told you the main purpose of all these lectures is to optimize the use of resources, whether it is irrigation, whether it is herbicide or farm machinery, or whether it is fertilizer. So in this case, we restrict our discussion mostly to fertilizers. And you know, fertilizers supply nutrients to the crop. And I have already told you that what should be the strategy to supply optimum doses of fertilizer. You know, there are a number of ways, but the most potent and effective way is to conduct fertilizer experiment, get the yield data and test it for significant. You know, fertilizer experiments are conducted. You get the results, go for analysis of variance, F-test. If your results are significant, then go for correlation and regression analysis, and then find out the relationship and see if it is quadratic relationship, you can work out the optimum dose of fertilizer. I explained you these equations are called as production function or response curves. So I gave you information about different kind of equations, and these equations result in lines. And these equations are also called as models. I've shown you different models, and you have seen two kind of equations, exponential equation and polynomial equations. In polynomial equations, you see the numerals are the power, 1, 2, 3, 4. These numeric number are power of the variable x. In exponential equation, it is exponent which is in power. And you have seen different types of curves and equations. And then how best we can find it out, it was explained to you. The method of least square is used to response curve fitting. Response curve fitting means to find out the equation that can represent your data in a best way, in the best possible way. That is your response curve fitting. And then I explained you method of least square. You see, these are actual data given by dots, and you need to find a line that can represent this data. And line is that if you get the differences of actual data, observed data, that here you have recorded from the field, and the predicted line, also you got the respective data, because these are paired observation. For every independent variable, you have values of dependent variable or respective values of dependent variable. And you take the differences, because some values are above the predicted value, means you got positive values, and some values of actual data are below the line. Therefore, the value or the difference will be in minus. So it is better to square these values and make the total. And the total sum of square, the line which is giving us the least values of the total sum of square is the best fit line. So today you will see how it is done. And then I told you about residuals, the data, the differences which remained unrepresented are actually residuals. You can see here the blue squares are your actual data, observed data, which is represented by capital Y. And on the line also you got some data, and take the difference, how far it is. And then you see these are all residuals represented by red line. And this is called as error. This data remain unrepresented by the line that we have estimated. If all the data points, if line is passing through all the data points, then there will not be any error. There will be zero error. And that will be the most best fit line. So here the main job is to reduce the distances or reduce the sum of square, or we should have the minimum sum of square values. And then I told you before fitting equations, I tried to explain you about the differences in correlation and regression analysis. What do we mean by this? Correlation means it simply tells us whether two variables are associated or not. For example, plant height. If your plants increase in height, naturally their dry matter will increase. So these two variables are related. Therefore, we can say that plant height and dry matter have some weight. See, in number of leaves also, if your number of leaves increases, the leaf area index also increase. That means these two variables, leaf area and number and leaf area, have some relation. Therefore, it is called as correlation. When two variables, one variable is affecting other, then it is said that two variables are related to each other. Or you can say a mutual relationship or connection between two or more things is called as correlation. When relation exists together, that is correlation. Now, regression in analysis is actually nature of relationship. It quantifies mathematically what is the relationship in mathematics terms. If I say I teach for 1 hour, then you can say that I study for 2 hours. So then there is some numerical relationship. I teach 1 hour, you study 2 hours. Then there can be relationship, but this relationship is numerical. I read 1 hour, you read 2 hours. So it is a numerical relationship. So such kind of relationship is regression relationship or regression analysis. So what we need to do that we need to collect the data. Collect the data means you say your fertilizer doses. Fertilizer doses are your independent variable. You collect the data on fertilizer, which is also input. And this fertilizer will be represented on x-axis of the curve. And then the data which is recorded on the crop, say yield, will be your dependent variable. And then we can plot the data, we can make a scatter plot and see what kind of relationship is suggested by the data, what kind of directions it is showing to us. And then we can fit the regression line by using the method of least square. And then once we have fitted the line, we are not sure whether it is truly representing the data, whether this line is truly a linear line, then we need to have some statistical test to see whether this line is a linear line. So some statistical tests are used, and that test is F-test. F-test will test the linearity of the equation, whether it is genuinely linear or not. So assessing the goodness of fit of the regression line using R squared and standard error of estimate. I will teach you today how to test the linearity of the equation and then once we have proved that this equation is linear equation or any kind of equation, then we can make predictions. We can make predictions by using the regression line. Now, what regression analysis tells us? It describes the effect of one or more variable, or there can be many independent variables that can affect one dependent variable. For example, grain yield can be affected by a number of variables, like fertilizer rate, and in fertilizer you have nitrogen, phosphorus, potassium, and so on. And it can be affected by water management, the amount of irrigation applied, the plant protection measures, number of plowings. So many variables are there that affect the grain yield. So, but it is very difficult to study all these variables, independent variables together, affecting only one dependent variable. So what normally people do, they take only one variable and see effect of this one independent variable on the dependent variable. Then this relationship is called as simple correlation and regression analysis. if you take two or more independent variable affecting one dependent variable, then this kind of relationship is called as multiple correlation. When two independent variable affect one dependent variable, this is multiple correlation and regression analysis. Regression analysis is a method for investigating functional. Functional here means numerical or mathematical relationship. The process of finding a mathematical model. How you find the model, how you find the relationship or numerical relationship between X and Y. It is called as regression analysis. Now let us see what is difference in dependent and independent variable. The variable to be predicted or modeled Y is called as dependent or response variable. I have already explained it to you, the difference in dependent and independent variable. Correlation exists between two variables when one of them is related to other in some way. You know about scatter plot, you have X value and you have Y values. So the data is in pair. The data is in pair, and then you can plot it on the chart paper or graph paper and see the trend of the data. This kind of plot is called as scatter diagram or scatter plot. I think you have already seen this scatter plot or scatter diagram. So here, I think no trend is visible. You cannot visualize whether the data is following a linear relation. The data on x-axis and y-axis, you see. The linear correlation coefficient. You can call it, simply you can call it correlation coefficient also, or you can call it linear correlation coefficient. It measures the strength of the linear association between paired X and Y quantitative values in a sample. So if you have a sample and you want to see the strength of relationship between two variables, then you need to calculate the linear correlation coefficient, which is called as R, small r. It is also called as Pearson product movement correlation coefficient, very long name, because Carl Pearson was the first person who found the formula to calculate the correlation coefficient. Now, I have already told you what is difference in simple and multiple correlation regression analysis. One independent, one dependent variable. This is simple correlation regression. Two independent or more. Two or more independent variable when they are modeled for one dependent variable. This is called as multiple correlation and regression. Now, I have told you what is positive correlation. Positive correlation is when one variable is increasing, other variable is also increasing. Or you can say when one variable is decreasing, other variable is also decreasing. Such kind of relationship is called as positive correlation. So consider the following saying, the bigger they are, the harder they fall. The more, the merrier. Merrier means happy. The more happiness. Means if you have more money, you are more happy. I don't know, but it is a saying in English. They call it proverbs. P-R-O-V-E-R-B. Proverb, or these are the sayings. Old people used to say it. The more, the merrier. If you have more money, more property, you should be more happy. So kind of positive correlation. Easy come, easy go. The better the deed, the better the day, the better the deed. So in all these cases, you are seeing that one variable is affecting other or increasing the value of the other. Then it is called as positive correlation. Take another case of negative correlation. Here, much haste. Much haste means you are in hurry. You are so fast, but speed is less. Much haste, little speed means there is negative correlation. Small pitches have big ears. The best gift comes in small packages. So all these sayings suggest that there is negative relation between two variables. If one is increasing, other is decreasing. Now you can see in the picture this positive correlation and negative correlation. And sometimes there cannot be any correlation. You can see the data in the picture. You do not see any trend. So here there is no correlation. Now, as I told you, there is difference in correlation and regression. Correlation is very, very qualitative, but regression is quantitative, numerical, or numerals are used here. So you can remember the definition of regression. This is very small definition of regression. You can see amount of change in one variable associated with a unit change in other variable. If you make 1 unit change in X variable, how many units changes are there in Y variable or dependent variable? This is called as regression. Correlation refers to the fact that two variables are related. Just it will tell us whether two variables are related, and closeness of the relationship. But the regression analysis tells us the nature of relationship. Now we can try to see the meaning of regression. A penny saved is a penny earned. So penny is a currency, money. So if you save 1 Afghani rupee, that means you have earned 1 Afghani rupee. So there is some mathematical, numerical relations. A bird in the hand is worth 2 in the bush. A stitch in time saves 9. One picture is worth 1,000 words. So you can see, you can put it in the tabular form also. One is independent variable, other is dependent variable. So penny saved, pennies earned. So 1 penny saved is 1 penny earned. So regression coefficient will be 1. Y is equal to 1x. Then you have hands, birds in your hand. Suppose you have 1 bird in your hand and 2 bird in bush. Then relation is y is equal to 2x. 2 in bush and 1 in hand. So y is equal to 2x. So the regression coefficient is 2. Means x is 2 times, or y is 2 times of x. Y is 2 times of x. Similarly, in the next case, y is 9 times x. So this is 1, 2, 9. And finally, y is equal to 1000x. So this is 1000 times x here, y. So you can see these are the regression coefficient. Hope you could understood the meaning of regression coefficients. They are important. So if you have equation y is equal to a plus bx. So in this equation, b is actually regression coefficient. Now, you can see more about regression coefficient and intercept because the equation is y is equal to a plus bx. So general equation, it is here. The symbol a is called the intercept. Intercept means when x has the value of 0. The value of y when x is 0 is called as intercept. Means it is just touching the y-axis. Hence, the line crosses the y-axis at a unit from the origin. When a is 0, the line exactly passes through the point of origin. The symbol b is called the slope. The b, as I already told you, it is called as regression coefficient, but it is also called as slope. Since it determines the steepness of the line. Higher the value of the regression coefficient, higher is the slope. You can say lower is the slope, means it is very upward. It is easy to see that b is the amount of change in y associated with a unit change in x. That is your regression coefficient. So therefore, it is logical to call b the regression coefficient. Now, friends, this was the little bit background. Now, as I told you, we are going to do the regression analysis and correlation analysis. We are going to fit certain lines, certain curves. So we will study under two headings. One is linear relationship and other is non-linear or curvilinear relationship. So here, we get data of independent variable, which is X, and we also get data of Y, which is called as dependent variable. Now let us learn more about linear relationship. If you miss any point here, if you want to discuss any point, you can stop me so that I can reply, I can clarify your doubts. And I have given you one book, Statistical Method by Gomez and Gomez. In that book, there is one chapter on linear relationship and one chapter on non-linear or curvilinear relationship. So you should read these chapters. This will be your homework. So you can prepare better in this subject. And friends, I tell you that this subject is very, very important for agronomy scientists, agronomy students. Because,
Sir,
yes,
sir, we will find from that book from internet or you will send.
I have already sent you. I
Okay.
sent you, the
And, okay.
few-
And which
uh,
and that chapter you will study for homework.
yeah. So let me say that I have already sent you book. When I sent you many books, you will find one book on, or maybe 2-3 books on statistics. I have sent you very good books on statistics. Just you need to see them.
Yes, sir. Yeah, you sent us more than 32 books. I checked in.
Statistic.
None.
Okay. So no problem. You can keep them. And if you need, I can send you more. And,
Yeah, exactly, sir.
and
I
thing
find
is- yes, please speak.
Okay, sir. Okay, sir. We will find the statistic books and will be solve the issues.
Okay. So now we start linear relationship. So relationship between two variable is linear if the change is constant throughout whole range under consideration. Means you have two variable, one is X, suppose fertilizer. If you increase the doses of fertilizer, the every dose increased will result in the same increase in the yield, same or constant or similar return with the each addition of each additional unit of fertilizer or input. Then such kind of relationship is called as linear. Every time same increase. So functional relationship between dependent variable Y and independent variable X can be represented by Y is equal to A plus BX. Friends, this is linear equation. And in this equation, we have not mentioned the error, but you can also put Y is equal to A plus BX plus E. Error is also there, which is not shown here. So in this, A is the intercept, means as I already told you that it is the value of Y when X is 0. And B is the regression coefficient, this B, which is change in Y due to unit change in X. Delta Y upon delta X is your B. It is called as slope of the equation. Deeper the slope means the value of regression coefficient are higher. Or shallower the slope, the value of the B is low. Now, if intercept A is 1, suppose Y is equal to 1 plus 2x. Suppose this is the equation. Then 1 is actually your A and 2 is regression coefficient. So if you make a change in X, if you put it 2 here, you will get 5. If you put 2 here, you will get 5. If you put 3 here, you will get 7. If you put 4 here, you will get 9. So every time there is change of 2. From 5, it has become 7. From 7, it has become 9. So every time there is change of 2. Therefore, it is a linear relationship. I repeat again, in place of X, if you put Y, 1, so it becomes 3. If you put 2, it becomes 5. If you put 3, it becomes 7. If you put 4, it becomes 9. So 1, 3, 5, 7, 9. So you see, every time there is change of 2. From 1 to 3, 2. From 3 to 5, 2. From 5 to 7, 2. From 7 to 9, 2. So therefore, this is example of linear relationship. So in above equation, 2 parameters of linear relation are specified. Here 1 is given and 2 is given. But most times it is not given. We need to find it out. We need to find it out. I will show you how we can find it out. Value of dependent variable y corresponding to a given value of independent variable x within the range of x values considered can be determined by replacing x in the equation with the desired value and computing y. So in this case, you have seen that you can put the value of x and you can find out the value of y if you know the value of a and b. So main problem here is to identify the value of a and b. So how we can find out the value of a and b, we will discuss shortly. So friends, in the last case, you have seen that it was relation of only 2 variables, one independent and one dependent. But there can be situation when there are many independent variables which affect one dependent variable. So many independent variable means k. K means many. So this could be x1, x2, x3. So equation will be y is equal to a plus b1, x1, b2, x2, and so on. So this is our multiple regression equation. In place of a and b, they have taken in place of b, they have taken b1, b2, b3, and so on. So this is multiple linear regression equation. Now we will go for regression analysis for linear relationship. Here, regression analysis for linear relationship means we are going to find out the equation. We are going to fit the equation based upon the data. That is the meaning. Or we are going to find out the numerical relation between x and y. So it tries to fit a model to one dependent variable based on one or more independent variables. Tries to fit model means to find out the equation. And once you have found out the equation, you can plot it because you can calculate the value of x1, y1, x2, y2, and so on. Then we can plot a line, we can make a line. But in most cases, you will get the error. The line will not represent the whole data. It can be a little bit away from the data point. So, but our goal is to minimize the errors from actual data to the regression line. Means line should be as close as possible to the actual data. That will be the best fit line, and method of least square minimize the sum of square of errors. Regression equation or line helps to predict the values of dependent variable based on given values of independent variable. Now, simple linear regression analysis we are going to do. We are going to find out the linear equation. We are going to fit it. So method for finding line of best fit between dependent and variable and independent variable is simple linear regression analysis. I repeat many times the things so that it becomes easier for everyone to understand. So now you see field experiments are conducted to record the data. You can record the data. Suppose you have heat, WHEAT, heat, you have applied fertilizer doses. So you can record the grain heat and you know the doses of fertilizer you have applied and the yield at different doses. You have noted down from the field. You have recorded this data. So you have X1, Y1, X2, Y2, X3, so on. And then recorded data are considered as actual data or observed data. This is used to fit the regression models. These fitted values give a regression equation or line that can be used to get the expected or predicted or estimated value. So from this equation, we can make predictions, or we can have expected value or predicted values or estimated values. The meaning of expected, predicted, and estimated value is same. They can be used synonymously. But before fitting any relationship, it must be ascertained that the results are significant. I told you that when you have recorded data from the field, the data must be tested for ANOVA. Analysis of variance must be accomplished. And then if our data is significant, if F-test, that is variance ratios are tested, if that is significant, then we can go for correlation and regression analysis. Now, method of least square is used to compute the linear regression equation. Now you can see here, try to understand this line. So these lines, now you see on x-axis. On x-axis, you have fertilizer doses, 0, 20, 40, 60, 80 kg per hectare. On y-axis, you have yield. Suppose yield in quintals per hectare, 10, 20, so on. And you have recorded the data that at control at 0. This was the yield. The black color Y, the capital Y is your actual data that you have recorded from the field, this Y. And then at 20, you have this, this blue one. The blue one is your actual data, which has red circles. So capital Y1 blue, capital Y2, capital Y3 blue, Y4, these are actual data. And you see the dotted line is represented by small y. So this is your predicted line. Now, how we can find out this predicted line? By knowing the value of B and A. If we can calculate the value of B and A, we can find this predicted line. I'll show you how it can be done. Now we are going to find out the value of B and A. So now suppose your fertilizer was nitrogen, say 20, 40, 60, 80. Here it is written N0, 1, 2, 3, or K. There can be any levels. Then output, the yield Y0, Y1, Y2, so on. Then expected values or estimated values are small y0, small y1, y2, so on. Now we need to see the sum of differences. Sum of differences, you can see this difference from this line to this line at different values. This difference, these are residuals. We need to see it. So sum of difference in capital Y minus Y. This is observed, this is predicted. So you can take like this, and this sum of difference, now you square these values. These values are to be squared here. Square here. You see, this is squared. And then the total of square value should be minimum. And this line will give us. And now see residuals, means observed data minus this data, minus A plus Bx0. I will explain you this. Now consider following linear regression equation or model. Y is equal to A plus Bx. In the equation, X is considered as independent variable, Y as dependent variable. Now here main thing is that we need to find out value of A and B. If we can find out the value of A and B, then we can put these values in the equation. That means we have fitted the line. We have made the line, or we have developed the line. This completes your regression analysis. So now how to find out the value of A and B? So value of A and B can be found out by calculating certain parameters. To find out value of A and B, we need to do some calculations. We need to do some calculation, and I will continue it in the next link. Now 2 minutes are left, and we can go to the next link. But during these 2 minutes, if you have any question, you can ask the question.
Thank you very much, sir, for your nice presentation. So, one of friends has questions.
بس سيدي لو غصب بروسها ضربته.
So, no question.
Okay, now we go to link to because it is expiring in 1 minute.
Yes, sir. So, sir, we are going to the link two.
Huh?
These are the-
Online next, yeah.
So we are doing recording. So I just told you that now we want to find out value of A and B. And to find out value of A and B, you can see this B. B means summation xy upon summation x square. So we need to have value of summation x square and summation xy to calculate the value of B. Similarly, to calculate the value of A, this is the formula. Y bar means we want to have means of Y and we want to have means of X. If we know the mean of X and mean of Y, and also if we calculate the B, then we can calculate the overall value of B and A, and we can put these values in the equation. So therefore, we need to calculate these parameters, xy, x square, y bar, and x bar. So how can we do it? This is your data. For example, this is x1, x2, x3, y1, y2, y3. Now you need to calculate these parameters. So we can calculate x bar means total of all values of x divided by n, number of pair of observations. How many pairs are there? I'll teach you one example also. Mean of y is equal to y bar. You know, y column is there and you make the total of all and divided by n, number of pairs of observations. And then we need to calculate summation x square. Summation x square. Here, x minus x bar is square. This is called as corrected sum of square for independent variable. Corrected sum of square for independent variable. X minus x bar. Then y square, small y square. Summation is small y square. You see, this is called as total sum of square. Total sum of square. It is some y minus y bar. Summation y minus y bar whole square. And this is called as corrected sum of square for dependent variable. It is also called as total sum of square. Then we need to have sum of square for cross product. Cross product, this is summation xy. Summation xy is equal to summation xi minus x bar, y minus y bar, and then you multiply these two. This is called as corrected sum of cross products. And you know, meaning of xi. Here you are seeing xi, yi. So the meaning of xi, you can see somewhere. This is xi, this is yi. This means ith pair. Ith pair, because there are number of pair, first pair, second pair, third pair. So we need to take all the pairs. N is number of pair. How many pairs are there? N. This n is number of pairs. How many pairs are there? Now, we can calculate the value of A and B. B is equal to summation xy upon summation x square. And then y is equal to, or A is equal to y bar minus bx bar. So now you got the value of A and B. Easy? Any problem in this? Is it clear?
It's clear, sir.
Okay. Now you see A and B. We have found out the value of A and B. And we can put this value in the equation. Y is equal to A plus bx. So in place of A, we can put the calculated value. In place of B, we can put the calculated value of B. Now we have got the equation. Now we want to test it whether this equation is truly or genuinely linear or not, which is called as regression test or testing the linearity of the equation. So computed equation, computed means calculated. Computed means calculated equation must be tested for its linearity, whether it is linear or not, whether it is a straight line or not. So for this, we have F test, which estimates the linearity of the equation. And variation is partitioned into different components and ANOVA is prepared. So friends, you know, we have fitted this equation and now we want to test the linearity. What we are doing actually here, we are going to test the significance of the regression coefficient. Regression coefficient is B. Now, so you see, first of all, there will be sources of variation. Don't worry, I'll explain you with the help of the example also. But right now, you see the theoretical background. Theoretical background. If I start teaching you some practical examples, then you will definitely easily learn. However, you can learn this one also. So there are number of sources of variation. First source was regression because we have fitted the equation. And you remember some data remained unfitted. Some data remained unfitted. Some is represented by the regression. Some is not represented. That is part of the residual or error. So there are two sources of variation here. One is regression and other is residual. And then you can make the total. Now, degrees of freedom. Friends, this is linear regression. Remember, in linear regression, for linear regression, the degree of freedom is always 1. Because here, y is equal to a plus bx. The power of x is 1. Therefore, we take 1 as degree of freedom for regression. If it is quadratic equation where the power of or maximum power of x is 2, then the degree of freedom for regression will be 2. If it is cubic regression, cubic means highest power of x is 3. Y is equal to a plus bx plus cx cube. Y is equal to a plus bx plus cx square plus dx cube. Y is equal to a plus bx plus cx square plus dx cube. Then it will be a cubic equation. Then degree of freedom for regression will be 3. It will be 3. You know, total degree of freedom is n minus 1. N means number of pair of observation. How many pairs are there? Suppose there are 5 pairs. Then 5 minus 1, so it will be 4. And for residual and error, we can calculate the degree of freedom simply by difference method. Total degree of freedom minus regression degree of freedom. So n minus 1 minus 1, it will give us n minus 2. So residual or error, you can put it n minus 2. So it is n minus 2 here. Now sum of squares we need to calculate, and sum of square can be written by small y square r. This is the symbol for sum of square due to regression. Sum of square due to regression. The formula is summation xy whole square divided by summation x square. This is called as sum of square due to regression. The value which will come here will be sum of square due to regression. Similarly, total sum of square. Total sum of square, I have told you. This is total sum of square, this one. This one is total sum of square. So this can be total sum of square is summation y square, small y square. So you know how it can be calculated. And then from these values, we can subtract this. This total sum of square minus sum of square due to regression. We will get this. So this is total sum of square minus regression sum of square, the above value. So you get residual or error sum of square. It can be calculated simply by difference method. Total sum of square minus regression sum of square. Now mean square. So mean square means this column divided by this column. if you divide sum of the square values by degree of freedom, respective degree of freedom, you get mean square. So sum of the square due to regression divided by 1. 1 is degree of freedom, you get mean square values. Similarly, here also, sum of the square due to error, all these values divided by n minus 2, you will get mean square due to error. Mean square due to error, mean square due to regression. And this cell divided by this cell, mean square due to regression divided by mean square due to error or mean square due to residual, it will give us F calculated. Mean square due to regression divided by mean square due to error, it gives us F calculated. Now we will get the value of F, and then we will get the table value of F. Table value, you know, table value can be seen in the table. You must have seen T table, chi-square table, or Z, or similarly, you must have seen F table. In F table, there are two columns. One is horizontal line, other is vertical line. So for F test, we have 2 degrees of freedom, two degrees of freedom. One is horizontal, other is vertical. So horizontal will be 1. Regression degree of freedom you will see horizontal, and vertical n minus 2. So degree of freedom is 1, n minus 2. So at 1 and n minus 2, we can see the table value of F, and then if our calculated value is greater than the table value, then regression is said to be significant. Regression is said to be significant. So just now I explained you, if your F calculated greater than table value, that means your equation is significant. What does it mean? If my equation is significant, it means that equation is truly a linear equation. Means it is representing the linear relationship. If my equation is non-significant, if F test fail, that means equation is not linear. So this was the test for linearity of the equation. If my equation is not linear, if it is non-significant, that does not mean that it will not have some other kind of relationship. It can have quadratic relationship, it can have cubic relationship, or it can have some other kind of relationship. But this test proves whether the equation is linear or not. So if results are significant, my equation is linear. If results are non-significant, my equation is not linear. So now you can see here, to calculate the respective mean square due to regression, sum of square due to regression divided by degree of freedom. I've shown you in the last slide. And sum of square due to error or residual, sum of square due to error divided by degree of freedom. Here F calculated, mean square due to regression divided by mean square due to error, you get F calculated. And compare F calculated to the tabular value of F, 1 and n minus 2 degree of freedom. It is linear relationship is significantly different if your F calculated value is greater than table value at 5% level of significance. Otherwise, we look for higher degree of regression. So now, friends, if you have any question on this, you are most welcome. Otherwise, we can go to the next presentation, next slide, or next PowerPoint. Do you have any question?
No, sir, no question.
So, friends, welcome. Today, there had been disturbance in the internet connectivity. I know it. So, we continue. Now, whatever I discussed up to now, you will see the practical use of it. Now, there is one example here. Example, with the help of example, you will learn all mathematics or simple mathematics that is involved in it. Example is a field experiment was conducted by taking different levels of nitrogen. There were different doses of nitrogen in mustard to test its effect on seed yield. Different doses mustard, and we wanted to see what was the effect of these doses on the yield. From the data given in table 5, next page I will show you some data. From that data, fit a linear response equation and test it for linearity. So you can fit a equation means find out a equation by regression analysis and test it for linearity, means whether it is a linear or not. Also plot. Plot means make a graph. Also plot the response curve from the computed equation and perform the correlation analysis. So you need to find the equation and plot it, make the curve or make the line of the equation. So I'll teach you now. And this is all done manually. You can do it with the help of simple calculator. Even without calculator, you can do it. So first of all, I teach you or I tell you friends that you do not use softwares straight away. First, we should know the background, the theory, the fundamentals. Then we can use computers. Whatever I am teaching you now, it can be done in 5 seconds by using Excel. In Excel program, you will do correlation and regression analysis very easily. And if you give me time, I will teach you how to do this analysis in Excel software using correlation and regression analysis tools. Every Excel program has this software. So I'll teach you continuously. But we should know the theoretical background. Now I have put this data in the table. You can see carefully. Computation means calculation of different sum of squares for estimation of constants A and B. You want to calculate A and B, and for fitting the linear response equation or linear curve. Then in the x-axis, you have nitrogen doses. This is independent variable, 0, 40, 80, 120, and total. Then yield in quintals per hectare. It does not matter whatever unit you have, only numerical values are important. So here you see 17.20, 18.5, 19.8, 20.5. So you can see the yield is increasing. Yield is increasing every time you increase the dose of the fertilizer. Now we want to see the relationship. So we can take the mean of this. We can take the mean of x. Mean of x can be taken. You can take the mean of x like summation x upon n. 240 by 4, you get 60 as the mean of x. Similarly, mean of dependent variable y bar or x bar, summation y upon n, 76 is the total, divide by 4, you get 90. So you can calculate the mean of this column and mean of this column. And you can get a small x. This is x minus x bar. So from every pair, you can subtract 60. 0 minus 60, 40 minus 60, 80 minus 60, 120 minus 60. You get these values. And you get 19 as the mean for y. You can get a small y, subtract 19 from here, 19. 18.5 minus 19, this minus 19, this minus 19. So you get a small y. It is difference of y minus y bar. Now you can square x square. So this is your x. If you square this column, you get x square. Then xy. This is your x. This is your y. Small x, small y. You multiply each other and you get xy. Then y square. This is total sum of square. This is the y, small y. Square this column, you will get y square. And make the total of all these columns. Make the total. So this total will be summation x square. 8,000 will be summation x square. This 224 will be summation xy. This y square will be summation y square. So you can see these values have been calculated x bar, y bar, and x square, and total is 8,000, and y square is total sum of square, it is 6.3. So now from these values, how to go for this test? Now summation xy, you know how it is calculated. I have shown you x small x minus into small y, and you get 224. Now from all these parameters, all these terms, these are called as terms, TERMS, terms. From all these terms, we can calculate value of b and value of a. Value of b is equal to summation xy divided by summation x square, small x square, and it was 224, you see, and put the value of summation x square, which was 8,000, you get value of b as 0.028. 0.028. This is the regression coefficient. This is also called as slope. Means if you make 1 unit change in fertilizer, nitrogen, then there is 0.028 unit change in x, y, yield. If you make 1 unit change in y, x, which is fertilizer, there is 0.028 unit change in y. So this relationship we have developed. Now we want to see whether this regression coefficient is significant or not. We should test it, or which is known as testing the regression coefficient or testing the regression equation. Now A can be calculated simply by difference method. A is equal to y bar minus bx bar. So y bar, we know the value of y, mean, value of x bar, we put the values here, and b value is this. This is our value of b. So you get 17.38. 17.38 is the value of A, which is intercept, means yield at control, which is 17.38. And friends, this is predicted yield at control, which is known as intercept. Now the linear equation y is equal to 17.32 plus 0.028x needs to be tested for linearity. We need to test it for linearity, whether the two variables are really following a linear relationship or have some other kind of relationship. Analysis of variance is performed. I have already told you. ANOVA is performed and variation is divided into different components. One is regression and other is error or residual. And F-test is used to see the significance. I have already told you. Sum of squares, mean squares, and total sum of squares are computed in the following ways using the table 5. Last table, the slope of a line, linear regression line, may be positive, negative, or zero, depending on the relationship between them. Many times you will find value of b in minus also. Value of b in minus, but that is not absolute minus. That is just telling us the direction of change. If relationship is negative correlation, one is increasing, other is decreasing, then the sign will be minus. If relationship is positive, then this regression coefficient will have positive sign. It cannot be negative. So whenever you get negative value of regression coefficient, that means it is just direction of the change. And the values are absolute. Values does not include your signatures. Signs, S-I-G-N. Now we can know it. Total sum of the square is 6.38. If you remember in the last table, we have calculated this was 6.38. If you remember, this is total sum of the square. So we can get it from here is equal to 6.38. And then sum of the square due to regression. Sum of the square due to regression. I told you it is by difference method. Total sum of the square minus error sum of the square. So it is 224 square 8,000. So it comes out to be 6.27. Then sum of the square due to error. This is sum of the square due to error or residuals, it is I'm sorry, you see the sum of square due to, I repeat it, sum of square due to linearity or regression. It is simply summation xy whole square divided by summation x square. You already have these values. You put these values, you get sum of square due to regression, 6.27. And this is by difference method. Total sum of square minus residual sum of square. Total sum of square, I have already told you, it is summation small y square. So this is summation y square minus all these values. So you get 6.38 minus sum of square due to error or residuals. It comes out to be 0.11. Now you see mean square due to linearity or regression. Now the sum of square values are divided by degrees of freedom. Sum of square due to linearity or regression divided by degree of freedom 6.27. Mean square due to residual or error. This is error. Sum of square due to residual or error. Degree of freedom 2.055. F calculated MSL. This value 6.27 divided by 0.055. You get 114. Now you can put all these values in the table. Source of variation is linear. Here, friends, linear means regression. Residual here means error. And total. Total, I told you, summation is small y square. So 1, 2, 3 is the degree of freedom, because here there are 4 pair of observation. 4 pair of observation minus 1, so we get 3. I told you for linearity, it is always 1. So 1, and then this residual is 3 minus 1. Means total degree of freedom minus regression degree of freedom will give us residual. Or directly you can remember it is n minus 2. N is 4 pair. So 4 minus 2, it will give you 2. Now sum of square values have been kept in the table. Just now we have calculated. Mean square values are here. And you divide this value by this value, you get 114. Now I have put these values by seeing the F table. 18.51 is at 5% level of significance and 98.49. So our calculated value 114 is far more than the 18.51. Similarly, it is greater than the 98.49%. 98.49. It means our results are significant because calculated F is greater or larger than the table value. Therefore, results are significant. It means our equation is a linear equation. It has passed the test of linearity. Now, we would like to see how closely it was a fit. Okay, it is significant. It is linear now. Now we want to see how closely it has fitted the data. So, for this, how closely it has fitted the data, we can go for calculation of correlation coefficient. So from the same data, by using the formula, we can calculate the correlation coefficient. Suppose correlation coefficient was just suppose 0.991. 0.991 was the correlation coefficient, which is represented by small r. So you can square this value. You can square this value. 0.991 can be squared. 0.991 into 0.991. It gives us 0.982. So this value, friends, is called as R square. R square means coefficient of determination. There are two coefficients. One is correlation coefficient or coefficient of correlation. Other is coefficient of determination. Coefficient of determination means if you square the value of correlation coefficient, it becomes coefficient of determination. I will explain in full detail what is meant by coefficient of determination later in the class. But for the time being, you can see the sum of, if you square the value, it comes out to be 0.982. You multiply this value by 100. If you multiply it by 100, that means 98.2. 98.2% variability in the grain yield of mustard has been explained by the regression equation estimated. Whatever regression equation we have estimated, we have found it is representing about 98.2% variability in the data. That means it is one of the best fit. So this is the use of coefficient of determination to explain the results. Here, I tried to explain you the results. So for example, I put the last slide. From the same data, we can calculate the correlation coefficient and explain it in this way. Now, next job is, we have found out the equation. What will be our equation? Because the equation will be y is equal to 17.32. Y is equal to 17.32 plus 0.028x. Okay, y is equal to 17.32 plus 0.028x. This will be our equation, and we have tested it for linearity. Now, same equation we want to plot. We want to plot it. You know, you are the really best student having good knowledge of mathematics. Now, if you know the value of y and x, you can convert this equation into, or represent this equation in the form of a graph or form of a chart. So using the estimated linear regression equation, y is equal to 17.32 plus 0.028x, compute the estimated y values. We can calculate the value of y. One corresponding to the smallest x value, x min is equal to 0, and the other corresponding to the largest x value, x maximum 120. Friends, in this equation, whenever we plot the equation, we take the lowest value of independent variable, which was nitrogen fertilizer here. We have taken 0 as the minimum value, and highest value of nitrogen fertilizer was 120. So if we take minimum value of x, then we can calculate the minimum value of y. So equation is y is equal to 17.32 plus 0.028x. So in place of x, if I put minimum value of x, which is 0, so you get 17.32. The value corresponding to x minimum, the y minimum is 17.32. Similarly, x max is 120. If I put 120 here, I will get 20.68. This will be y max at x max. X min will give us y min. So friends, after 15 minutes we meet. After 15 minutes. We meet after 15 minutes. You can have a break. So friends, welcome back again in the class. So I have told you that 4 values are to be taken. 2 values are already known to us. One is x min, minimum value of x, that is fertilizer, which is 0. And we can estimate the value of y when x is 0. And that y will be called as y min. Similarly, x max, maximum dose of nitrogen or fertilizer or input or independent variable is 120. So we can put 120 in the equation and we can estimate y at maximum x. It will be called as y max. Now you can see, you can just put these points. This is y min point, and this is y max. So just put the dots and join the line. Join the line, it will be a linear response curve. or it is a straight line. So you can clearly see the purpose is served. Means you have seen that we have estimated the equation, found out the equation, and then we have tested whether it was significant or not. We found that it was significant, and once it was significant, we have done some predictions, some estimated values were calculated at x0 and x120, and those 2 points y0 and y120 were plotted and they were joined. So here you can see one interesting fact, that r square is equal to 1. If you take the under root of this, it will be correlation coefficient. So here correlation coefficient is also 1, and coefficient of determination is also 1. So therefore you can see the line is touching both the points. Line is touching both the points. That means 100% data. 100% data has been represented by this line. There is no error. If r square is 100%, then there are no residuals. There are no errors. So this could be the best fit line. Do you have any question?
Sir, can you explain that grain yield Q per hectare?
Q is a unit which used to have in India, it was quintal. So 1 quintal is equal to 100 kg. So if you multiply it by 100, it will become in kilogram.
You can tell some kilo.
Yes, thank you, sir.
Okay. So it is just, it can be 1732 kg, 1732 kg. So you can multiply it. It will not change the result. Result will remain the same. So now I'll discuss all this. Suppose your equation is 1 plus 2x. Y is equal to 2x plus 1. You can write either way. You can write y is equal to 1 plus 2x or 2x plus 1. It does not matter. Here also you see r square is 1. So line is passing exactly through the original data. This line is showing the predicted data, but it is passing through all the points, data points. That means here also r square is 1 and the residual is 0. So you see 1 plus 2x. So now you can put value 0 here. If you put 0 here, then it will be y is equal to 1. Y is equal to 1. And then if you put 1 here, y is equal to will be 3. Again, you can put 2 here, 5. So it will go on like the 1, 3, 5, 7, 9. And every time there will be change of 2. So therefore, rate of change is constant here, which is 2. So 2 is your regression coefficient. A is intercept. So you can see here intercept. So intercept is, the line is originating from the intercept. Because even at control, when x is 0, you will have some y. And that y is called as A, intercept. So it is here from 0 to 1, it is 1. So 1 is intercept, which is here A plus bx. So there is a change of 2 units. Now, friends, as my friend asked me, what was Q? So this Q was quintal. Now see some characteristics of the graphical representation. See the characteristics of the graphical representation of the linear regression. In the last picture, you have seen the graphical representation of the equation, linear equation. Now you see the characteristics of this equation. The line must be drawn within the range of values of x min and x max. It is not valid to extrapolate the line outside this range. That means the line should be plotted only for 0 to 120. 0 to 120, because our lowest or minimum level was 0 and highest was 120. So we cannot extrapolate it. We cannot go for 160, 140, 130. we have to remain only up to 120. We cannot extend it. We cannot go outside these limits. So therefore, the extrapolation is not allowed. This is number 1 point. Number 2, the line must pass through the means of both the variable x and y. So this line must pass through the mean of both x and y. Somewhere you will have mean of both here. So it should pass through the mean of both the variable x and y. One common point of mean will be there. The slope of the line is b, also called as linear regression coefficient. The line, if extended, must intersect the y-axis at the y value of a. Y value of a, I have shown you this one. Now, computation of coefficient of correlation and determination. I already promised you that I will tell you how to calculate the coefficient of correlation. It tells us the strength between two variables, between nitrogen application and mustard yield. So how can we calculate the coefficient of correlation and coefficient of determination? So friends, coefficient of determination is the proportion of variation that is accounted by regression out of total variation. There may be total variation in the data. If you remember, total mean is square, and there may be variation due to regression. The ratio of this is your coefficient of determination. The important features of the correlation coefficient. So first of all, you see what is correlation coefficient. And features. The values of correlation coefficient lies in the range of -1 to +1. This is the range. The extreme values indicate perfect linear association, and mid values of 0 indicate no linear relationship between two variables. So here, if you have 0, left side, if you continuous 0.1, 0.2, minus, but it will go towards minus. On the right side, it will go towards plus. So, so it is irrespective of the sign. Sign are not considered actually. It is the absolute value. Sign tells us the direction of change. If you have negative correlation, then the values will be in minus. If you have positive correlation, value will be in the plus. But the higher values indicate higher coefficient of correlation or higher correlation between two variables. Now this calculated R can be squared. You can square it. For example, in the last case, we have calculated the R value of 0.9. 0.9 was the correlation coefficient value. The implication is you square this value. So 0.9 into 0.9, it becomes 81%. So 81% means the variation in the variable y can be explained by the linear function of the variable x. Means 81% data is showing that I am linear, but remaining 19% data is not falling on the line or not represented by the line. That is our error. So this is how we can explain the meaning of coefficient of determination. The minus or plus sign attached to the R value indicates the direction of change in one variable relative to the change in other. It is just direction of change, whether you have positive or negative correlation. It has nothing to do with the absolute values. Even though the 0 R value indicates the absence of linear relationship, sometimes you will get very small values of correlation coefficient, maybe 0 also, but it does not mean that the absence of any other relationship between them. It can have some other kind of relationships, maybe quadratic, maybe cubic, maybe so on. It is possible for two variables to have a non-linear or curvilinear relationship instead of linear relationship. Now, friends, we can compute how to compute R square. The value of R does not change. Now see the features of the correlation coefficient. Continues. Number 5. The value of R does not change if all values of either variable are converted to a different scale. My friend was asking about quintals and kilogram. So if you change the values in different scale or different unit, the correlation coefficient will remain same. If I convert quintals per hectare into kilograms per hectare, so it can be 1730 or something like that in kilograms, then the value of correlation coefficient will not change. If I change the fertilizer value into, say, tons per hectare, same numerical values, then it will not change the correlation coefficient. Another point, another characteristic of correlation coefficient is the value of correlation coefficient is not affected by the choice of X or Y. In place of X, you can write Y and vice versa. So interchange of all X and Y values and the values of R will not change. R means correlation coefficient measures the strength of a linear association. It is not designed to measure the strength of an association that is not linear. Suppose curvilinear relationship, quadratic relationship, we cannot have linear correlation coefficient initially, but we can get it after linearizing the quadratic, cubic, or any polynomial equation can be linearized by some statistical methods, and then we can calculate the linear correlation coefficient. However, straightway we cannot calculate linear correlation coefficient if our relationship is quadratic, cubic, which is called as non-linear or curvilinear. Now, friends, suppose you have got value of correlation coefficient as 0.9. In the last case, the calculated value was 0.9. So how can we say that it is significant? How can we say that it is significant? Friends, we need to test the significance of correlation coefficient here, because just I seek your attention. Whenever we do t-test, f-test, chi-square test, z-test, or r-test is test of correlation coefficient, is called as r-test. So whenever we do these tests, what is the purpose? So basically, we have taken samples from the population. We have taken sample from the population. See, large fields are there, and we count only few plants. So we take data from the samples. We do not count the all data from the whole field. That is called as population. So from population, we take the sample. There can be number of errors in taking the samples. So here, we want to overcome those errors that might have occurred during the sampling that we want to overcome here. So for this, we are not sure that it is truly representing the population. So therefore, this test is required that it is truly representing the population, and this sample is giving the right result. So for this, we need to go for testing the significance, whether it is due to some chance factor or it is really a relationship exists between two variables. Now, the sample of the pair data is a random sample or quantitative data, means numerical data. The sample data have not been collected using some inappropriate method. So it is wrong. We should follow all the sampling procedures. Then, visual examination of the scatter plot must confirm that the points approximate a straight line pattern. So first of all, we should go for a scatter plot and see that this data is showing some linear trend. Then we can go for fitting the data. If the visual observation is showing some other kind of relationship, then we should not go for calculation of correlation coefficient. Any outliers must be removed if they are known to be errors. Outliers are the data points which are not normal. Suppose the data range of yield is from 3 to 5 tons per hectare. This is the range of data, all data. But one data is giving you 9 tons per hectare. One data is saying 9 tons per hectare. So it is not possible that all the data are falling from 3 to 5 ton. But how come only one data is giving 9 ton? So that is called as outlier, which is not representing the range of the data. So that kind of data should be removed. Now, the procedure of computing the simple correlation coefficient is given below. So friends, you can recall, first of all, we have done the fitting the equation. We have found out the equation mathematically. You remember we calculate the value of A and B by formula, by doing some calculation. And once we have found the equation, if you remember, we have tested it for significance, whether the equation is linear or not. And then we have plotted it, we have made the graph or chart. And after that, we are doing now correlation analysis, and we are also going to calculate coefficient of determination. So this is recapitulation. By step, we could understood up to now. And we will see what next can be done, 0.5 or 6. On the left side, you are seeing the formula of R, correlation coefficient, summation xy divided by under root summation x square into summation y square. You remember these products were already calculated. We have made the calculation. If you can recall, here somewhere I have shown you that we have calculated these values from here. You remember summation x square is here, summation xy is there. So all these parameters have been calculated by us. For the same, we are calculating the value of correlation coefficient. So we can put all those values here. And in this case, we found that correlation coefficient is 0.991. Now, as I told you, that we need to test whether this correlation coefficient is significant or not. Means I told you about population and sample. So we want to see here whether it is genuinely a difference in the correlation coefficient or it is genuinely significant. Now, friends, there are two methods to test the significance of correlation coefficient. Select a significance level. So first of all, we need to select a significant level, whether you want 5% or you want 1%. Normally, we take 5%. So here, 5% level of significance can be taken. Now, friends, see method 1. In method 1, testing the significance of correlation coefficient, we use t-test. T-test, it is the t-value. T-value we are going to calculate. T calculated and R divided by under root 1 minus R square divided by n minus 2. So this is the formula to calculate the T statistic or T calculated. So now you know critical value of TR from table with n minus 2 degree of freedom. So here you will get the table value of T at 5% level of significance and at n minus 2 degree of freedom. Remember, it is t-test. So degree of freedom is only 1. If it was f-test, in f-test, we have 2 degrees of freedom in the table. So now you can put R value. R was 0.991. If you put 0.991 here, 0.991 here, n is the number of pair of observation, and then you can calculate it. See the calculated t value at n minus 2 degree of freedom. If your t calculated is greater than t table value, then it is significant. Otherwise, it is non-significant. So this is one method. And other method I will explain you. Method 2 is by Fisher. R.A. Fisher, you may be knowing the name. R.A. Fisher is considered as father of experimental design. R.A. Fisher, who has given F-test. You know, the name F-test comes from Fisher. So now you see how to calculate by t-test. So in t-test, you see hypothesis. This is your population correlation coefficient. Population correlation coefficient is 0. And alternate hypothesis that it is not 0, or it is not significant and it is significantly different. So T is the same formula. What you have seen here can also be written as in the next slide. N minus 2 will go up. You remember, it will become R into N minus 2 divided by under root 1 minus R square. So this formula can be rewritten like this: R into under root N minus 2 divided by 1 minus R square. So here you can put value of R and value of N. So you can calculate the T value. So here T value is 35.66. T value is 35.66. So you can compare it. The calculated T value is 35.66, and the table value at 5% level of significance is 2.0739. That means our correlation coefficient is significantly different. Now another method is given by Fisher. It says the distribution of correlation coefficient are for samples from a bivariate normal population. You don't bother about it. And what Fisher has done, he has given R table. You have T tables also. Similarly, correlation coefficient tables are available. Based upon degrees of freedom and level of significance, you can see the table value of R, table value of correlation coefficient. And if your R values, the calculated R values are greater than the table values, then R is significant. So, but the results from both methods are same. So you can do either. But this method is very simple. Suppose you have 0.0, you see in this is correlation coefficient table. As you have T table, F table, similarly R tables are available. You can find from internet. And then this is 0.1, 0.05. So 0.05 means 5% level of significance. 0.01 means 1% level of significance. 0.001 means 0.1% level of significance. Suppose you have taken 5 and your degree of freedom is 4. Just assume the degree of freedom is 4. Then 0.811 will be your table value of R. If your calculated value is greater than the table value, calculated value of coefficient of correlation is greater than this value, then it is significant at 5%. If it is less than that, then it is non-significant. Similarly, you can also see at 1%. At 1%, suppose it is 0.917. So if your calculated value is greater than this, it is significant. So if it is significant at 5%, you can put 1 star. If it is significant at 1%, you can put 2 star, showing the significance of the correlation coefficient. Is it clear to all of you?
Yes, teacher.
Okay. Now you can test here. The calculated value was 0.991, and your degree of freedom was 2, n minus 2. So it was n minus 2 degree of freedom. So suppose pair of data were 4. So you will have 2 degree of freedom. At 2 degree of freedom, at 5%, the value was 0.950, and at 1%, it was 0.990. Then you can see it is significant. It is significant because the value, both values are lower than the calculated value. Now, friends, suppose your correlation coefficient is 0.991. You can square it. It will be 0.982. And you multiply 0.982 by 100. So it gives you 98.2%. So 98.2% variability in the data, variability in the yield of mustard has been due to nitrogen application. This is relation of nitrogen application and grain yield of mustard. So therefore, 98.2% variability in grain yield of mustard is due to nitrogen application. This equation suggests like this. Remaining is your error. So you can see how to write it, that 98.2% of the variation in Y can be explained by the linear function of the variable X. Other ways to write it, when you write thesis or research paper, so you can write it 98.2% of the variation in the seed yield of mustard can be explained by the linear association between the seed yield of mustard and the nitrogen application rates. So these are the interpretation, friends. These are the interpretation how we can write it in English language. Other meaning is 100 minus 98.2 is equal to 1.8%. So this this indicates that about 1.8% of the total variation in seed yield of mustard can be explained by factors other than nitrogen application rate, or 1.8% of the total variation in seed yield of mustard remained unexplained. We do not know the reason. For 98.2% variation, it was nitrogen which was responsible in the equation. 1.8% is the error. So friends, I hope that you could understand the interpretation of correlation coefficient and coefficient of determination. Now, let us have some interesting points about coefficient of determination. So now, what is coefficient of determination? To be very simple, it can be explained as square of the correlation coefficient is coefficient of determination. But it can be defined in different ways. It is the sum of squares due to regression. Sum of square due to regression when expressed as a proportion of the total sum of square. You remember we calculated sum of square due to regression, sum of square due to error, and total sum of square in the analysis of variance. So from that table, we can take the ratio of sum of square due to regression divided by sum of square due to total sum of square. So it measures the amount of variation in Y accounted by the variation in X. R square indicates the proportion of the variation in the dependent variable explained by the model. For the present example, the R square is. So you can calculate R square. See, this is how you can calculate sum of square due to regression divided by total sum of square. I have taken this data from the same table. So it is 6.27 by 6.38. So you see sum of square is calculated directly. And you remember you have calculated a correlation coefficient by different formula. And here R square is calculated by different formula, which is 0.982. If you take the under root of this, if you take the under root of 0.982, it will come 0.991. So which is your coefficient of correlation. So therefore, they are directly related to each other. The value of R square is the proportion of the variation in Y that is explained by the linear association between X and Y, or simply by the regression, linear regression. The values of R square quantifies the goodness of fit. How fit is our equation? How best is the fit? A fraction between 0 and 1 and has no limit. If you remember for coefficient of correlation, the data ranges from, the result ranges from -1 to +1. But in this case, there is no minus. It varies from +0, or you can say from 0 to +1, and it has no unit. It has no unit. Higher value indicate that curve comes closer to data. If you remember in one picture or two pictures, I have shown you that line was passing through the point. Then it was, the value of coefficient of determination was 1, means 100%. 100% it was represented by regression, by association. There was no error. So higher values indicate that curve comes closer to data. And many times you will find that sometimes people write capital R square or small r square, capital R or small r. To be honest, there is no difference. You can write capital R or small r. It makes no sense. You can use any one of them. Similarly, capital R square or small r square, you can use synonymously or interchangeably. When R square is 0, the best curve fits the data no better than a horizontal line going through the mean of y values. When R square is 1, all points lie exactly on the curve with no scatter. There is no scattering or spread of the data. If we know x, we can calculate y exactly if your R square is 1. We can think of R square as a fraction of the total variance of y that is explained by the model. Only R square is not the main criteria for whether a fit is reasonable. A high R square tells us that the curve came very close to the points, but does not tell that the fit is sensible in other ways. Now, friends, I just recall or recapitulate the things. I'm going slowly on this topic. So first, you remember, I recall fitting the equation. We have made the equation. We have tested whether it was linear or not. And then if it was linear significant, then we have made a chart or graph. And just now we have calculated R square and correlation coefficient. And we have done interpretation of the meaning of correlation coefficient and coefficient of determination. And finally, last step or fifth step is residual analysis. And I repeat, if you have any difficulty in this, you can consult the chapter on correlation and regression analysis in Gomez and Gomez book. I have taken most of the knowledge or information from that book. So whatever you miss, please read that chapter. I repeat, that will be your homework. Now, friends, this was all about linear relationship. Now we deal with the non-linear relationship. What would have happened if our results were non-significant when we tested the linearity of the equation? In our case, the linear equation was significant. But if it was non-significant, then that means that it may have some other kind of relationship, which will be called as curvilinear, or we can call it non-linear or curvilinear relationship. But remember, in curvilinear or non-linear relationship, linear word is there. See, it can be non-linear, means part of it is linear. In curvilinear also, it is partly linear. So the relation between variables when the regression equation is non-linear, quadratic, cubic, or higher order is called as curvilinear or polynomial kind of relationship. It is a form of linear regression in which the relationship between the independent variable x and the dependent variable y is modeled as the nth order polynomial. So in the last case, equation was y is equal to a plus bx plus cx square. But in this case, it is y is equal to a plus bx plus cx square. So it is a form of linear regression in which the relationship between the independent variable x and the dependent variable y is modeled as nth order polynomial. The curvilinear relationship among variable is quite common in biological organism, including crops. You see in our crops also, initially seed germination is there. I have already explained you at the time of seed germination, it is very slow growth. Then it start increasing slowly and the growth rate is very fast. And then it again becomes constant. So you have, you can recall the sigmoid curve kind of things. So the response to a variable is rapid at the beginning, slower at the intermediate level, and could even become negative at high level of the variable. So this kind of relationship is sigmoid kind of relationship, or you can call it quadratic kind of relationship. So pattern of plant growth over time, which usually starts slowly, increases to a fast rate at intermediate level and slows down towards end of the life cycle. So such kind of relationships are curvilinear relationships. Curvilinear relationship is a polynomial type of relationship except the linear. The regression models or equations of polynomial type are quadratic, y is equal to a plus bx plus cx square, cubic, y is equal to a plus bx plus cx square plus dx cube, and so on. So these are the non-linear relationships. So if you remember here also we need to calculate the value of a, b, and c. In the last case, we have calculated value of only a and b. But here one more variable has come, which is c. In last case or linear case, you were knowing that rate of change was same. Rate of change was constant with the addition of each unit. But here, there could be two kind of rate of change. One could be faster rate of increase, and other could be slower rate of increase or fall. So the faster rate of increase will be represented by regression coefficient b, and c will represent the constant or slower or negative rate of increase or rate of change in the growth. So therefore, it becomes quadratic. So last minute is left. We go to the next. Do you want me to continue or do you want me to stop here? I wish that we can have 15 minutes more. Otherwise, it is up to you. So friends, here also we need to find out A, B, and C. So what happens? You see there are powers, power 2, power 3, power 4, and so many polynomials are there. So it is not easy to solve these equations. It is not easy to solve these equations. Now things become a bit difficult because we need to linearize the equation. If our equation is in curve form, if it is in curve, are you seeing the mouse? I am running on the slide. Can you see the mouse? Mouse?
Yeah, please. Yes, yes, of course.
It is visible. So if I make a curve, so from the, if it is a straight line, so a straight line passes through the graph. It will pass from the corner to corner of the graph cells. But if it is a curvilinear, if it is a curve, then it will not pass exactly through these squares. So we cannot measure the distance. So therefore, these equations are to be linearized. First they are converted into linear equation. Then methods of least square. Method of least square is employed to find out value of A, B, and C. So how linearization of the equation is done, I do not know that procedure. That is some statistical procedure. But I understand that we need to linearize this equation, make it a straight line, make it a linear equation by some transformation. In statistics, usually, people do some transformation of the data, transformation of the equations. Then transformation of equation is done so that it is linearized. Means then it will not have x power. It will not have x power. Instead, it will have x1, x2. So what is done here, you can see here, two data, polynomial, first degree, second degree, third degree, fourth degree. So here you can say this is your graph paper. Okay, graph paper. In a straight line, the red color you are seeing, it is first degree. So here the data point is easy to measure in data point. Then second degree is your polynomial. Second degree polynomial is quadratic. So here you see it is only one curve, one band is there, only one band is there. In linear, there is no band. There is no band. Band means curve, kind of curve. This is curve, bending. Here, in case of blue, you see fourth degree. There are 1, 2, 3 bands. If the degree is 4, then you have, so these are represented by x square, x power 3, x power 4, isn't it? X power 1, x power 2, x power 2, x power 3, x power 4. If it is quadratic, quadratic is your second degree, the green one. So in green one, you can see there is only one band or one curve. So this is x square, means this in second degree you have one band, in third degree you have two bands, in fourth degree you have 3 bands. So curve type is equal to number of bands plus 1. So if you have 3 bands and if you add 1, then it will be quartic of fourth degree. Hope you got the meaning of this. Then in response curve fitting, non-linear, what we need to do first the fit the quadratic equation, means we need to find out value of ABC, then test the significance of curvilinearity. In the last case also we have done F test. So here also we need to do F test, then plotting the quadratic response curve. Then we will plot it the way we plotted in linear response curve. Then we need to calculate the value of R and R square, same way. Then we need to test the significance of correlation coefficient and draw the inferences out of R and R square. And then we will compute the optimum economic dose of the fertilizer. So in the next 20 minutes, I will finish it. Please be patient and I request you to be sincere. Whosoever are sitting can hear it sincerely so that there are no doubts in your mind. Now, the response to fertilizer, plant population, irrigation, other inputs generally follows quadratic relationship. You remember sigmoid curve. In case of fertilizer also, number of experiments have been conducted across the world and people have established that response of fertilizer to grain yield or crop yield is normally quadratic. Response of plant population is also quadratic. Similarly, we can have plant height to the crop yield. Leaf area index can be related to the grain yield. Your nutrient uptake, nitrogen uptake can be related to the grain yield. So likewise, many variables can be related. And these variables, independent and dependent variable may have quadratic relationship. As the biomass yield increases in the field, the rate of increase or rate of change in the biomass is almost following the quadratic return in relation to nitrogen uptake or nutrient uptake. But before you need to conduct the field experiment and get the data, you will be using different levels of fertilizer and getting the grain yield. So you will get data in pair X1, Y1, X2, Y2. Similarly, you will get data as you got in linear relationship. Now, whatever data we have got, we need to go for F test, means ANOVA, analysis of variance. If our results are significant, then we go for correlation and regression analysis, like we did in linear relationship. Same thing we need to repeat here. Now, friends, this is the data. I have taken same data from the Gomez and Gomez book. If you miss anything here, you can consult the book. So now we will understand how value of ABC can be calculated by this example. So fit a quadratic equation or linear or non-linear or curvilinear relation from the data given in the table and calculate the optimum economic dose of the K2O when the cost of 1 kg K2O is rupees 10 and price of 1 quintal rice is rupees 500. So in this case, there are 2-3 problems. First is that we need to make the equation or fit the data to find out quadratic equation, then test it for linearity, go for correlation and regression analysis, and then from this equation, you need to apply some economic principles. So here X is rate of K2O application. Instead of nitrogen in this experiment, you can take potassium or muriate of potash. The levels of K2O are 0, 30, 60, 90, and 120. Here, remember, N is equal to 5. And these are the grain yield in kilograms per hectare. You can have grain yield in ton per hectare also. You can have any unit. Now, creation of new variables. As I have told you, that these equations are curvilinear. They are not linear equation. The rate of change varies here. Initially, the rate of change is fast and then it decreases. So therefore, we need to create new variable. We need to linearize the non-linear equation. This is a non-linear equation and this is to be linearized. I told you, I do not understand the theory behind it, but you see, the equation was like this. Y is equal to A plus B. Here you can put it for population. Y is equal to alpha plus beta 1x plus beta 2x square. So here you see the power is 1, 2, 3, 4, 5, 6, 7 like this. So such an equation can be linearized by creating small k new variables like Z1. Instead of this beta 1 or beta 2, we can have Z1, Z2, Z3, Zk to form a multiple linear equation of the form. By some relationship, we can linearize this equation. Now your equation will be y is equal to alpha plus beta 1 Z1 plus beta 2 Z2 or plus bk Zk. So likewise, we can linearize the cubic equation, quartic equation, quintic equation, any power. Those equations can be employed and then these will be straight lines and then we can calculate the value of A, B, and C. So friends, this kind of analysis has been done by a statistician. I could not get the meaning of this, but this is how we can calculate the value of A, B, and C. So now the counterpart, the equation is y is equal to alpha. Alpha is representing your A in the sample. Beta 1 is B and X, and this Cx square is your X, this beta 2 is your C, represented by C. And this X is converted into Z1. This X is converted into Z1. You remember this X is converted into Z1 with some relationship, and then X square is converted into Z2. So it is now linearized form. It is not polynomial form now. So now, friends, you need to calculate number of variables, from this data, you remember this data. So here, this is X. So you can calculate the mean of X. Mean of X can be calculated. Mean of Y can be calculated. And from this 0 minus mean of X, 30 minus mean of X, similarly Y bar. So mean can be subtracted from this to get several terms. Now we will be getting several terms to calculate the value of ABC. To calculate the value of ABC, we need to calculate number of terms. So friends, this is X. This is X. There are 5 levels. This is grain yield. There are again respective 5 levels. And now the first one is Z2. Z2 is equal to X square. So you need to square the first column. So 0, 0, 30, 900. So you got X square. Then small Z1. Small Z1 is actually Z1 minus Z1 bar. So you know what is Z1? This is your Z1 column. Z1 column. So this minus mean. So we have calculated the mean of Z1 and you get minus 60, these values. Then Z1 square. This column number 4 can be squared. column number 4 can be squared, and then Z2. Z2 means Z2 minus Z2 bar. This Z2 is, friends, column number 3. You can take the mean of this. The total is 27,000. Divide by 5, you will get the mean, and then subtract the mean from these values. Subtract the mean from these values, you will get this Z2 column. Z2 minus Z2 bar. So mean was 5,400, and you subtract 5,400 from these values, then you will get this Z2. Next is square the column number 6, you will get Z2 square. Then Y, you'll do similar kind of calculation for small y. Small y is Y minus Y bar. So this is your Y. You take the mean of this, and subtract the respective values. So here, the mean was subtracted, and you get the values, these values you get, if you subtract the mean, and then total will be 0. You see, total will be 0. Here also total is 0. I think that much mathematics you understand. Then next is column number 9, Y square. You square the values of the column number 8, you get these values. And then column number 10 is summation Z1Y. So small z1. So here you get small z1. And this is your capital Y. Capital Y is this. So you need to understand these symbols to calculate these terms. Next is summation small z2 capital Y. So z2 is your column number 6 and capital Y. So similarly z1, z2, small z2. This is small z1 and this is your small z2. So cross products and you get. So then you get all these parameters. It is very simple explanation. You try to understand. If you have any problem, you can talk to me or you can send me email or you can discuss in next class. Now you see mean of X is actually Z1 bar, which is 60. Mean of Y was 5824. Mean of Z2 is 5400. So you have calculated number of these terms. These are the terms, TRMS terms have been calculated. From these terms, we can calculate value of ABC. Now, you can calculate the value of the ABC like this. B is equal to summation Z2 square. All these parameters you have just now calculated, and you can put these values, you will get value of B. Similarly, value of C, you don't need to remember this formula, but whenever required, you can use this formula if you want to do calculations manually. And friends, we should do calculation manually if we want to keep our brain active. Otherwise, it will become inactive. I suggest you not to use calculator. Rather, we should use pen, pencil to make big calculations. Then C can be calculated by putting these values. And you see, value of C has come in minus. That means rate of change is going, you are having now negative correlation. Minus sign means you are having negative effect of, if you increase the value of X. After certain point, when it is increasing, the regression coefficient is B, then it is positive. But when the regression coefficient C comes into picture, the fall is start, the decrease is start. Therefore, the sign is in minus. Now, overall, you have calculated the value of ABC, calculated the value of B and C. So value of B and C is calculated. Now value of A can be calculated by Y bar minus B Z1 bar minus C Z2 bar. You place these values here. Hello, I think you are disconnected. Hello.